Hello everyone, welcome to another exciting video, and this time we are going to be talking about writing and solving one-step inequalities. So we're shifting our focus from expressions and equations and now looking at inequalities, things that are not equal. Okay, so there's some very important vocabulary here, very important vocabulary that I want you to keep in mind here, and probably highlighted that too much. There we go. We have this symbol here, the less than symbol. We have the greater than symbol. We have this, which may or may not be new to you, the less than or equal to. And we have this one that points to the right, the greater than or equal to. And there's some extra terminology here that you're going to see coming up in word problems. So when you are solving a word problem or looking for a solution of a word problem when it comes to inequalities, I want you to be referring to this table, especially if you're not 100% sure. Now, before we move on here, there's an exploration activity that I want you to do before you start this video. If you have not done this, pause the video now, do section A, B, and C, then come back and we'll go over this in the video. Okay, so I'm assuming that you have already gone through and done the exploration activity. Let's talk about it. Let's see if what you came up with matches what I was looking for. So we know that when we apply any operation on both sides of an equation, the resulting equation is still true. So for example, let's say I had 6 plus 4 equals 10. We know that's true. We know 6 plus 4 does equal 10. Well, if I take away 4 on both sides of the equation, I now have 6 equals 6, which is also true. So if I do something to both sides of the equation, the result is still true. Well, let's see what happens when we have inequalities. Well, I have this inequality here. 2 is greater than or equal to negative 3. That is a true statement. And I want to add 3 to both sides of that inequality and see what happens. So I'll add 3 here and 3 here. Well, 3 plus 2 is 5. And I'm saying that that's going to be greater than or equal to negative 3 plus 3 is 0. So that is still true. So our second one, we have negative 1 is less than or equal to 6. And I'm going to add a negative 1 on both sides of that. So if I add negative 1 on both sides, my new inequality is negative 2 is less than or equal to 5. And that's true because I do know that negative 2 is less than 5. So I'm going to say that that is a true statement. And finally, I want to add a negative 8 to both sides of this inequality here. Negative 8 is greater than negative 10. Negative 8 plus negative 8 is negative 16. And I'm saying that's greater than negative 10 plus negative 8, which is negative 18. And if we think about a number line, negative 16 is closer to 0, which means it is greater than negative 18. So that is a true statement. So let's look at question A here. When you add the same number to both sides of an inequality, is the inequality still true? And we got true in every case. So yes, it is still true. And explain how we know that the assumption would still hold for subtraction. Well, we know it will still hold it will still hold because subtraction is the same. It's the same as what? That's right, the same as adding the opposite. Okay, we know that because 2 minus 1 is the same as saying 2 plus negative 1. Okay, well, let's look at division. let's see if things still hold true with division. Okay, so we have 4 is less than 8, and I want to divide both sides by 4. So if I divide both sides by 4 here, I get 1 is less than 2. That's a true statement. 1 is less than 2. My next inequality, I have 12 is greater than or equal to negative 15. And I want to divide both sides by 3. And so if I do that, my new inequality is 4 is greater than or equal to negative 5, which is a true statement. And for a third one, I want to divide negative 4 into negative 16 and 12. And so my new inequality here is negative 16 divided by negative 4 is positive 4, is less than or equal to 12 divided by negative 4 is going to be negative 3. And so that's going to be, wait just a second, 4 is not less than or equal to negative 3. 4 is greater than. So something happened here. Something happened here, and we have a false statement. So maybe you already connected the dots, maybe you already figured it out, but let's try it again. Let's make sure that this wasn't a mistake that we made. So we have 15 is greater than 5 for our last inequality, and I want to divide both sides by negative 5. And so if I do that, it's going to give me negative 3 is greater than negative 1. Well, that's not true either. Negative 3 is less than negative 1. So let's look at question B here. What do we notice when we divide both sides of an inequality by the same negative number? And will the same thing happen when we multiply both sides by the same negative number? Well, it becomes false. And the same thing is going to happen with multiplication, because multiplication is the same as dividing by a reciprocal. Okay, we remember that from the fractions unit. So for example, if we multiply by a 1/2, that's the same as dividing by the reciprocal of 1/2, which is 2. So what could we do to make the inequalities that are not true into true statements? Well, we can flip the sign. So if we came over here where our false statements are and we flip the sign, well, let's now say that 4 is greater than or equal to negative 3. Well, now that's true. And negative 3 is greater than negative 1. Well, we can change it to negative 3 is less than negative 1. And so if we flip the sign, now the inequality is a true statement. And we are going to flip the sign when we multiply or divide by a negative. Okay, let's now jump right into the Cornell notes on the back side, and let's look at some examples. So my first example, I have a, x plus 5 is less than negative 12. So whatever x plus 5 is has to be less than negative 12. So just like with an equation, there are two sides to your inequality. So to get rid of this plus 5, I will subtract 5 from both sides. That gets rid of the 5's and leaves me with x is less than negative 17. So x has to be less than negative 17 for this inequality to remain true. So let's pick a number that's less than negative 17. I see over here on the number line that negative 20 is further to the left than negative 17. So if I put in a negative 20 in for x, and I evaluate, I get a value of negative 15 is less than negative 12. So the solution that we have here, x is less than negative 17, works. So to graph this, I'm going to put open circle at negative 17. And when I put an open circle there, I'm saying that I'm not including negative 17. But I am including everything to the left. So I'm going to shade everything to the left. Okay? So when we have a less than or a greater than sign, use an open circle. All right, let's look at B. Let me label this number line so we don't get that confused. And this one will be B. B, we have 8 is less than or equal to y minus 3. And so we're going to add 3 to both sides. And that gives us 11 is less than or equal to y. And I want you to flip this. If your variable isn't first, I want you to write it with your variable first. So we're going to write this as y is greater than or equal to 11. We're going to put a closed circle here at 11 because we're saying that we're including 11. It can be greater than or equal to 11. And then we're going to shade to the right. Okay, take a minute, pause here, and then do your turn 1, C, and D. All right, so let's go over your turn C and D. We have y minus 5 is greater than or equal to negative 7. We're going to add 5 to both sides of our equation, or inequality, which gives us y is greater than or equal to negative 2. So put a closed circle at negative 2 and shade to the right. For D, 21 is greater than 12 plus x. Get rid of our positive 12 next to the variable by subtracting 12 on both sides. That leaves us with 9 is greater than x. And we want to flip this. We'll write this as x is less than 9. So if 9 is greater than x, x has to be less than 9. Okay, open circle at 9. And shade to the left. Okay, let's look at multiplying and dividing. Similar process to solving equations. We have y divided by 3 is greater than or equal to 5. We have dividing by 3 here, so I want to multiply by 3 over 1. That cancels out the 3's, and I'm left with y is greater than or equal to 15. Close circle at 15, shade to the right. Looking at F, and this one is E and this one's F. Looking at F, I have negative 4x is greater than 52. So whatever this value is, this will be greater than 52. Realize that we're multiplying a negative here by something. Well, if we want something that's going to be greater than 52, think that x has to be negative here, because a negative times a negative is what? It's a positive. All right, so we'll divide both sides here by negative 4. And we get x. Remember to flip your sign. X is less than 52 divided by negative 4 is negative 13. Open circle at negative 13 and shade to the left. Now, why can't this be x is greater than negative 13? Well, let's put in a value that's greater than negative 13 for x. Let's put in negative 10, because I know negative 10 is greater than negative 13. So negative 4 times negative 10 is greater than 52. Well, that gives me 40 is greater than 52, which is not true. Okay, so that's why we're flipping the sign here. If I flip the sign and I pick a value that is less than negative 13, I will get a case here that's true. All right, go ahead and pause the video and try G and H. Okay, let's go over G and H. We have negative 10y is less than 60. So we'll divide both sides of this equation by negative 10. And that gives us y is greater than negative 6. Don't forget to change your sign. So open circle at negative 6 and shade to the right. Okay, and then let's look at H. We have 7 is greater than or equal to negative t divided by 6. I'm going to go ahead and flip this now, and I'm just going to rewrite this as negative t divided by 6 is less than or equal to 7. It's always nice when your variable is on the left-hand side, but remember, if you're going to flip the inequality, flip the sign too. All right, so from here, we want to get rid of this negative and the 6, so we'll go ahead and multiply both sides by negative 6. That cancels out both the negative and the 6. And over here, we have 7 times negative 6 is 42. And think about the sign that's going to go in the middle here. If we multiply or divide by a negative, the sign flips. So now we're saying that the value of t has to be greater than or equal to 42. Negative 42. Okay, let's look at a couple of real-world situations here. Real-world situation I. Every month, $35 is withdrawn from Tony's savings account to pay for his gym membership. He has enough savings to withdraw no more than $315. For how many months can Tony pay for his gym membership? So if we look back up here at the beginning of our notes, no more than means it has to be less than or equal to. So we go back here. He withdraws $35 per month, and it has to be less than or equal to $315. Okay, so to solve this, we'll divide both sides by 35. And we have m is less than or equal to 9, which means Tony can pay for no more than 9 months. All right, pause here and take a look at the return 3 problem. Okay, let's take a look. Submarine descends more than 40 feet below sea level, which means it's going to descend even less than 40 feet below sea level. Keep in mind here that your sign is going to be less than, because this submarine is going to travel less than 40 feet below sea level. That sounds a little confusing, but think about it this way. We're descending. Okay, the more we descend, the more negative we get, which means the more less we become. Okay, and as it descends from sea level, the change in elevation is negative 5 feet per second. So negative 5, and I'm going to use t for my variable for time. So I'm saying that the amount of time, and that's 5 feet per second, is going to be less than negative 40. So we'll divide both sides by negative 5. And it's going to take more than 8 seconds. It's going to take more than 8 seconds to descend that more than 40 feet. All right, you will need to complete the summary and have that ready to go in class tomorrow. And be ready with any questions that you might have about these notes.